Okay, so now that we've taken a look at the limitations of using an environment light for our diffuse lighting, and then also a look at the 3 different passes that we're aiming to create for our diffuse lighting, those being just the light information, just the shadows information, and then finally the diffuse surface color of our surface that determines what color of light that surface reflects. Let's now turn our attention to the diffuse lighting component only, the light information, so no shadows, no surface color, just the lighting coming from our environment. And earlier we discussed how we processed our HDRI in such a way to generate that diffuse convolution, which gives us an environment map where we can use the surface normal of the point being rendered to look up into that map and determine the diffuse light reaching the surface in that direction. So if we take a look at one of our earlier whiteboards, there we go, we can see that we were talking about rendering a surface, and when we rendered a point on that surface, we find a normal, we use that normal to work out a latitude, longitude on our environment map, and then we use that to find the pixel, and that pixel in the image gives us the intensity value of lighting that would reach the point being rendered, and that is of course the intensity value of diffuse lighting. Now luckily in Houdini it's incredibly easy to implement this or such a lookup like this for a mantra render, because we're provided with an environment map VOP, and that VOP simply lets us specify an image to use as our environment and a direction to use as the lookup, and once we have that image and the direction, it will output the color that it finds in that image. So we're going to have something that looks something like this in our shader. So I'm going to create a new layer and grab my brush. There we go. So we're going to have an environment map VOP. I'm going to abbreviate that to envmap, and it's going to, we're going to specify an image on there, we're going to pump in the direction that we want to use for our lookup, it's going to output a color, and if we take that color into our output 1, which we know has a CF input, we can simply wire that in, and whatever color we look up in our map gets output as the final rendered pixel color for our render. So how do we calculate what direction we want to use as a lookup? Well, we saw that earlier when we were discussing how the image was processed, and that is we're using the surface normal. The image is processed in such a way that we simply use the surface normal as the lookup into the map. So the environment map VOP has a direction input, and we can take our global variables. So this is our global variables, which we know is called global 1 by default in our network. And we can take the N output of this, the surface normal output, wire that into the direction input of our environment map, and that means for every point being rendered, we determine the surface normal of the point being rendered. We use that as a lookup into our environment map, and that's going to then output the color of our HDRI for diffuse lighting based on that lookup, and we simply take that and use it as the color that's being put in our final rendered image. Now notice there's no multi-sampling involved. That was the main limitation when using, as we jump back over into MPlay, when using our environment light. We saw that we had multi-sampling for our basic diffuse lighting pass, even though there's no need to do this. The shader that we're about to implement is not using multi-sampling, it's simply using a single calculation, a simple algorithm per pixel that we're rendering, and that means it's very, very efficient. This is a very quick pass to render. So now that we've taken a look at the nodes we're going to be creating and sort of how those nodes work at a very basic overview level, let's jump over into Houdini and actually implement it. So I'm going to jump into Houdini, and the first thing I want to do when I'm in Houdini is delete out our environment light, because we don't need that light anymore. So I'm going to delete our environment light, and down inside our shader I'm going to delete our Lambert VOP, And I am going to save our texture and UV coordinates for later. They're going to be useful in a later video, but for now we don't need them. What I do want, however, is an environment map VOP. This is the VOP that's going to allow us to specify an image and specify a direction, which we use as a lookup into that image, and that allows us to then generate a color based on that lookup, which we can output in our rendered image. So I'm going to name this to Diffuse Light, and we want to make sure that we use our Diffuse HDRI as the environment map. So you may say, well, let's go ahead and specify that on our environment map. But the thing is, we don't want to hard code that into our shader, because the HDRI that we're using for diffuse lighting will vary depending on the scene that the shader is being used for. So even in a project where a single HDRI is used for all shots, we may want to be making a shader that can be used on a later project, or on some projects we may actually need to use different HDRIs for different shots. So it's always good to build something that is as generic and as accommodating and as reusable as possible. So we really don't want to hard code into our shader the location to the map. What we want to do is have that as a parameter on the shader. So I'm going to middle mouse button on the environment map input of our diffuse light, of our environment map VOP, and I'm going to create a parameter node. Again, that was middle mouse click on that input, and I'm creating a parameter node, which I'm going to name to diffuse env map. And now on this parameter, I can browse on the string, and let's actually make sure that we give this a parameter name of diffuse env map as well. And I'll leave the label as color map for now. But here for on the string tab for the image default, I'm going to browse to the diffuse HDRI, and that means that by default that's the HDRI that we're using. But if we make sure when we later have an asset created, we promote up this parameter and allow for changing it, that means that we can very quickly, when we're setting up an asset, we can very quickly specify where our HDRIs need to be for diffuse or later on for reflections, and that means we can reuse a shader for multiple different projects. So I'm going to browse, and I'm going to browse to HIP and HDRIs and diffuse. I'm going to grab our 256 convolution diffuse.tiff. If we accept that, that's going to use that now as the environment map for our environment map VOP. Now I'm going to take the normal output of global 1, wire that into the direction of our environment map, and that now means that the surface normal of the point that's being rendered is going to be used as the lookup into our environment map, into our diffuse HDRI, and the resultant color we can wire into CF of output 1, and that means the resultant color is what's rendered in the final rendered image. Now, we know that by default our lighting is overexposed, so I can actually take the tint color and I can set that to 0.5, 0.5, 0.5, and that basically replicates the brightness modification we made earlier when we set up the environment map, or rather the environment light, because again we know by default our image really was overexposed for diffuse lighting, so I'm simply tinting it by multiplying its value by 0.5 before we output, and that simply means that again in the rendered image we get back, we're not dealing with an overly exposed image, we're dealing with something that's ballpark wise where we need it. Now the last parameter we're going to be looking at on our environment map VOP is the transform space, and this is a very important parameter because it specifies if we need to transform our direction vector from the space that it's in currently into a new space before we use it as a lookup into our map. Now our direction vector is the surface normal, and natively in Mantra the surface normal is actually in camera space, and therefore the orientation, if you will, of our environment map is going to be relative to the orientation of our camera and not as it needs to be to the orientation of the world. And that currently means that if we were to render now and then rotate our camera and re-render, that would reorient our lighting, and that's obviously not what we want, but we can go ahead and demo that really quick. So I'm going to jump into our scene and I'm going to make a render, And the first thing I notice about this render is how much quicker it renders compared to our earlier passes. So there you go. And there's our diffuse lighting, which appears to kind of be working. But now if I was to rotate the camera, so let's rotate up and over like such, just to demonstrate nicely, and re-render. There we go. Notice how the lighting in this particular orientation is very heavy, coming round to the front of our teapot. But notice how it's not, or rather to the side of our teapot. Notice how that lighting isn't present in this view. The view that we're looking at is reorienting our environment map. It's reorienting the direction vector, if you will, of the surface normal, because that surface normal is related to our camera space. And we want to make sure that by rotating the camera, we aren't affecting the environment map. The environment map has been set up in such a way that it simply exists in world space. So what we need to do, as I make sure I look back through our camera, is over in our shader, as we jump down into our shader. Fantastic. Over in our shader, I need to make sure that we don't leave it in the current space, but rather we make sure that whatever the surface normal space is, which we know to be camera space, it gets transformed over into world space before we render. So if I bring from the drop down transform to world space, you see that it transforms it into space : world, and that means that we're going to take our surface normal, we're going to put it over into world space, and then use that world space surface normal as the lookup into our environment map, which is the behavior that we need. So now if I was to re-render, just give this a second to render. Notice there's our lighting information, and if I was to reorient the camera, so let's say this time I rotate round, let's rotate back up and over, kind of like we had before, which I believe was something like that, and re-render. Notice how the lighting corresponds now between those different views. The lighting is fixed in world orientation, not in camera orientation. That's very important. You also notice, as I don't need this image anymore, let's remove it. You also notice how quickly these frames are rendering, and also they're absolutely clear. There is no noise, there is no multi-sampling going on. It's absolutely crisp, absolutely clear, because we're simply using a lookup into our diffuse convolution of our HDRI. So I'm going to save this image because we are going to use it for comparison purposes later. So I'm going to save this frame as I jump to, I'm going to jump to S project, HDRI shader, and I'm going to save this as our diffuse light.pic and accept, save, okay. And that has now concluded setting up our diffuse lighting pass. In the next video we'll continue on and we'll take a look at how we can deal with the shadow pass. So as I bring up our layers, in the next video we're going to be looking at diffuse shadows. So that is going to conclude this video. Thanks a lot everyone.